Hello everyone, today we are going to talk about dark adaptation and light adaptation. Does everyone has the experience of encountering a glare vision when you move from a dark room to a bright room? Or a blind vision when you move from a bright room to a dark room? Do you know what is this so? Stay tuned, we will let you know the answer soon. In our eyes, there are two important photoreceptors which are rods and cones that play a major role in this process. Rod is a photoreceptor cell which is sensitive to dim light and responsible for monochromatic, dark adapted vision, which is called scotopic vision. The visual pigments of rods are called rhodopsin, and each rod molecule will consist of two major parts, which are opsin and retinal. On the other hand, cones, which concentrated at the fovea, have a greater role in the absorption of different colored light, such as green, red, and blue. Thus, it provides a fine detailed image and responsible for colored vision that we call as photopic vision. It's also quite specific to light wavelength as we know, vision acuity. There are three different classes of cones which we refer, that is for short wavelength sensitive, S cone, middle wavelength sensitive, M cone, and also L cone that stands for long wavelength sensitive. However, due to cones are less sensitive compared to rods, thus it requires more light to be activated. Now, let's see how the rod system is carried out. During dark condition, rhodopsin is accumulated in the eye and consists opsin and cis-retinal molecule. However, when our eye exposed to the sunlight, bleaching of the pigment happens. The light will be absorbed by the rhodopsin and cis-retinal will be transformed into transretinal. The rhodopsin will be broken down into transretinal and opsin. When moving to a dark condition, regeneration of pigment occurs where the enzyme will slowly convert the transretinal to the cis-retinal. The cis-retinal will combine with opsin to form rhodopsin, and rhodopsin is accumulated again. For the cone system, the method to carry out is similar to rods, just that the cones need a higher intensity of brighter light since they are less sensitive to rods. However, the cone photopigments recover from bleaching at a faster rate than does rhodopsin, as it takes about 1.5 minutes for 50% of a cone photopigment to recover following bleaching, while for the visual pigments, rhodopsin will take 5 minutes to recover 50% of it when the quantity of rhodopsin is bleached. So, what will happen as a person moving from a dark to bright room? Yes, he or she might feel uncomfortable at first when seeing a lot of glare, and actually, they are experiencing light adaptation. As the light is low intensity, there is no or just a few amount of rhodopsin is bleached. However, when moving from dark into bright light, I will receive a large amount of light, and rhodopsin are broken down immediately. The rods and cones will stimulate it strongly, and they need some time to process it, thus producing a glare due to the high intensity of light. After some time, the rod system is turned off at first, and later cone system will adapt it. Once in the dark, rhodopsin will regenerate and the sensitivity of the retina will increases over the time. First of all, our pupil will constrict. Let's see this picture. This is what behind our eyes. Here is optic nerve or the blind spot. At the middle part is our fovea, where the cones are located. So our macula is surrounded by many of rods and is located periphery. Simple to say, in our eye, rod is more than cone. When light enters the eye, pupil size will constrict to allow light focus on the center of macula and pass through the cone. Then, when the light go in, all of light will hit on the photopigment and cause bleaching the photopigment of rhodopsin of the rod cells. First, the cis-retinal is tight bound with the opsin protein to make rhodopsin. When light hit it, cis-retinal will be converted to transretinal and the opsin will release. So, this will cause rod to turn off. When rod turn off, retinal sensitivity decrease, while cone turn on, visual acuity increase. So how about when a person moving from a bright to dark room? At first, he or she could not see anything and all dark vision because they are actually experiencing dark adaptation. At the low intensity of light, cones will not functioning as there is no light to activate it. Pupil size will start enlarged to allow as much light as possible to enter the eye. When there is no light, rhodopsin bleaching will not occur and regeneration of rod pigment starts, where the transretinal form will be converted to cis-retinal form. The cis-retinal form will combine with opsin to form rhodopsin and sensitivity of the retina will increases over the time. As a result, rhodopsin is accumulated and it starts functioning for night vision during the dim light. This process also takes some time to ensure enough rhodopsin for a person to see properly.